This is so funny. This is my take 2, and my name is Mrs. France. I'm from Mrs. Bailey's pre-calculus class at Altus High School, and I'm doing number 4 from the Unit 5, number 4 homework. Okay, so the work I've already done and erased part of it because this is take 2. The given says secant theta equals 3, and that the sine of theta is greater than 0. But after considering my own work in the key, the information that I also want to add is that the cosine of theta needs to be greater than 0. In other words, the sine and the cosine are both positive, and that would restrict my theta to quadrant 1. Now, since the secant is the hypotenuse divided by the adjacent side, I've placed that 3 over 1. And then I did the Pythagorean theorem in order to get the opposite side, which is 2 square roots of 2. Okay, I'm going to adjust my paper for a second. A sine of 2 theta. The formula for that is 2 sine theta cosine theta. Okay, and then I'm going to go ahead and place values. 2. You can see my erasure there. This is the sine. It's the opposite over the hypotenuse. 2 square root of 2 over 3. And then the cosine is the adjacent side over the hypotenuse. And let's multiply through. 4 square roots of 2 over 9. And that's my answer. Okay, let's see if I can fit everything in. B. B is for the cosine of 2 theta. Okay, I'm going to use cosine squared theta minus sine squared theta. Okay, I'm going to place values for that one too. Here's the cosine, 1 divided by 3. I'm going to square that quantity. And here's the sine, 2 square roots of 2 divided by 3. And I'm going to square that quantity also. 1/9 minus 4 times 2, which is 8, 9th, equals negative 7 divided by 9. Okay. Great. Let's move on to C, which is the sine of theta divided by 2. Okay. The equation I'm going to use is square root of 1 minus cosine theta divided by 2. Because I've restricted theta to be in the first quadrant, I'm going to choose the positive square root this time. Okay, let's place some values. Square root 1 minus the cosine, 1 divided by 3, quantity divided by 2. Okay. Simplify. Underneath the radical, 1 is actually 3 divided by 3, so 3 minus 1/3, that's 2/3 divided by 2. Simplifying again to 6, 1/3, square root of 3 divided by 3, and that's my answer. And again, I chose because the sine in the first quadrant, remember I added this is the first restriction given by the author Gene Adams, but I added the second restriction. So here, this cosine right here, we don't have any problem. We don't have to think of any other place but the first quadrant. Okay? That kind of simplified this question for us, because I know that there are some people who are worried about what the potential for quadrant 2 could have been. Cosine theta divided by 2. I'm in quadrant 1 because I gave the second given restriction, I'm going to use 1 plus the cosine of theta divided by 2. Okay? 1 plus and 1/3 divided by 2 underneath the radical. I'm sort of running out of space. 1 is 3 divided by 3, so 3 plus 1 is 4. 4/3 divided by 2, quantity underneath that radical. So now I'm going to have 4 divided by 6, which is 2/3. And I'm going to rationalize the denominator. So I'm going to multiply both by the square root of 3 divided by the square root of 3. So I'm going to have the square root of 6 in the numerator divided by 3. And I'm done. Thank you.